Hello everyone and welcome to another SuncatByte. This SuncatByte is during office hours, so we may have some questions during the SuncatByte as it's a live lecture. But this SuncatByte is going to be about functions and pass by reference. So when we talk about functions and passing by reference, different than pass by value, and the thing that we need to think about and why we even have functions and pass by reference is this question. How can the C++ programmer obtain more than one value from a function? The answer to this point is we can't. We haven't been able to do that because we only have one return statement in a function, so that's all we can do is get one value from a function. But in order to remedy this, we can do this. We can pass the address of a variable or variables to a function. If we do that, we can then change the value, our values of the value of those variables. So then, like we just said, given the variable's address, the function can assign values into the address locations. Let's look at an example with a diagram. So if we look at this diagram, the whole purpose of what we're doing here is just basically a function to ask for x and y. So without getting into the mechanics of how you do this, just think big picture. Big picture, we have int main, which is a function, right? Inside of main, we have x and y that are declared. Then we have the ask for x and y function. Instead of passing these by value, we will pass them by address or by pointer, basically, right? We can use a pointer is one type of way to pass an address. So here we have a pointer. This pointer here, this pointer here. So step 1 is the declaration, step 2 is the call. Step 3, we're going to pass the address, which are references to the function. So they're pointers, that's why it's pointing here. Then inside of this void ask for x and y function, we actually have the addresses of ff14, ff10. So those reference these main variables in memory. Those are referencing these variables of x and y. So we have y here, x here. Then inside of the function, this guy here is pointing to y. This guy here is pointing to x. ff10 is the address, ff14. So then inside of the function, when we enter x, we can say put the value for x in ff14. So we say put the value here because we have the address. I'm sorry, here. So if they enter 15, it goes there. Then same thing here. Put value for y in ff10, it goes there. Notice there's no return statement. So there's no return statement because we don't need one. We can actually do everything we need to do by having that address, by passing by reference. All right. Now the mechanics of how we do that is basically this. By using pointers, the address operator, and the indirection operator. So address operator is this guy. Indirection operator is the pointer. So it's we don't want that. How about this? This is the indirection operator there, the asterisk. Okay, so this technique, at least the first way we're going to look at it, is called all kinds of issues over here. There we go. Is called function call by reference using pointers, or also pass by reference using pointers. when we do this, we're going to use the indirection operator. So by doing that, we're going to explicitly pass the address explicitly. There we go. Pass the address of a variable to a function using the address operator, and then the function stores the address in a pointer variable, and it then uses the indirection operator access to calling functions variables, just like we saw in the example above. And what the indirection operator is doing is it tells the program, go to the address that I am holding, or that I am pointing to, hence a pointer, right? So let's look at an example, which is basically our example above, but with some of the actual syntax that we would use. So first off, here's our prototype up at the top. In the prototype, we have ask for x and y. Notice it's a void. We don't have to have a return statement now because we're going to change things via pointers. So here you have the name, and then indirection operator, the type of int, type int, and then you have the indirection operator for each variable, and then the variable name. So pointer to x, pointer to y. Then in main, we declare x and y. When we pass x and y in, we're passing the addresses of them using the address operator. So ask for x and y. Then here in the call, in the definition, and there's more stuff in main here, but we're not concerned with that right now. In the definition, here's the header, right? Header always matches the prototype. So int star px, int star py, right there. Matches it in terms of syntax, right? You have to have the same types and stuff here. These could be different names. But anyway, you got to have that indirection operator there and there, just like you do up here. Then when you read the values in, you say, hey, read it in and use the star again, so where I'm pointing to. Okay, so this is the syntax to do this. Keep in mind, when we do this, these are pointers. So these are actually pointing back to these variables. So say we wanted to do this in a different way. What if we said, well, I want to have a return statement, but I still want to do two values? We could do something like that. We could do it this way. Okay, if we did that, here's our prototype. It's going to return something. In this case, it's going to return x. And then we're going to get the value of y by the pointer. So here we have int x and y. Notice we have x equals because we're going to return x, but then we're going to pass in the address of y. So inside of the function, we have to create this temporary variable x to read x in. So we say cout, enter two ints. Then we have cin x. So now x has a value. Then star py. So this guy got read in. Once we did this, it actually wrote it into y there because we have the address because it was passed in by pointer. Here, x doesn't get a value until we do the return x. Then we come back, this whole thing evaluates the value of x, then it gets assigned there. So just another way to kind of combine the two. Really unnecessary because we can really just do it this way, right? And avoid the confusion of having a return statement and passing by reference. Reference using pointer. So something to think about is, in the old days, pointers assisted the programmer in writing memory-efficient code. So one thing to think about, is that. Another thing, they can save time in memory because you're not declaring a bunch of different variables. You're not having temp variables inside of functions, sorry. Normally, if a variable is passed to a function makes its own copy, right, of data with the pointer. The function accesses the data directly. So just what I basically said out loud there. And then finally, if you had large data items, something like pixels, it's best to only have one copy. When we get to arrays later in the semester, we'll also see that those are large data items, and they get passed in by reference automatically. All right, so that is function call by reference using pointers. Pass by reference using pointers. And that was available in C. In C++, the C++ language streamlined that address passing concept. Okay? And it does it by doing this. Provides programmers with the call by reference technique for passing a variable's address to a function that uses reference parameters. What it basically does, and the whole point of this, is it makes the syntax a little bit easier. Okay? So a reference parameter is an address and it's implied, though not plainly expressed, as an address. Okay, so when we do this, it's going to be called call by reference with reference parameter, or pass by reference using references. So the function, in this case, the function prototype and the header line contain reference parameters. Then the ampersand is used instead of the star, the indirection operator, which we use in call by reference with pointer parameters. Okay? In the call statement, just the variable name is used. So in the call statement with call by reference using pointers, we have to use the address operator. So you don't need it here. So in this new type of call by reference, addresses are passed to the call function and accesses the calling function's data, just like the one above. Reference parameters employ the reference operator in the function declaration. And it's also used in the function prototype and function header line. So that's the same thing, right? Because this reference operator in the function declaration, the declaration is the prototype. Call statement has the variable names in it, but their addresses are being passed to the function. Now an example, the same example as above, but I want that. Take those off there. But instead of call by reference using pointer, we're using call by reference using reference. So in this case, we have the ampersand in the function prototypes, the address operator. In the call, we're just using the variables of x and of y. In the function header here, again, address operator. We're going to enter two ints, and then we're going to read them in. Notice when we read them in, we don't have the indirection operator here. So this is exactly the same from a functional perspective as using the pass by reference using pointer. It's just a little bit cleaner syntax. So let's look at an example, or a couple of examples. First one. Okay, we'll let that open. So first one will be, we have this name and age pets. Basically what we're going to do is we're going to ask for some info, the name and age and number of pets, and then we're going to output it. So here, notice in our other examples in the lecture piece of this, or the notes piece of this, we had two parameters or one. We had the first one we passed in or changed two parameters. This one, and then the next one we had a return statement. We changed one. This one we're gonna have three. So you can have as many as you want. And this is pass by reference using reference, or call by reference using reference. Open this so we can look at the other example after. Let that go. Okay. So here, void ask for info. Here's our address operator here, here, and here. Okay, the address operator, if it's there, it needs to be in the header down here, and there it is. So now the call, in this case, does not have, because it's passed by reference using reference, you just use the name of the variable. And then down here, just the name of the variable. Okay, so let's keep this in mind though. You gotta have this little placeholder in your head here. So we're coming in, age and pets exist. All right, there's age and pets. They exist in main memory. They exist in memory, right? No value at this point. Now we say ask for info, name, comma, age, comma, number, pets. That happens, we go to this call here. Now this guy, our name, gets the address of name. This one, our age, gets the address of age. This one, our numpets, gets the address of numpets. So here when we do the get line, it's saying, hey, this is where I'm pointing, read that data in. So as soon as we put a value in here, it goes to where it's pointing, which was to name, our name, which is here, and it writes the value there. Now when you enter age, same thing, goes to where our age is pointing, which is at age, value there. Now where our numpets is pointing, which is there, to numpets, and we get the value there as well, the integer. Once that's done, we're now return here. Notice I didn't have to have this assigned to anything because I didn't return anything. It's a void function, right? Now we write the info for name, age, and numpets. Those all have values now, whatever we entered here, so it's going to get output. Hi, Bo, I see you are 21 years old and have one pet. I have one dog. His name's Kobe. So there you go. Let's build it. Let's run it. Bo, age is 21. Number of pets I own, 1. There you go. So I prefer this method over the other one we're going to see, which is pass by reference using pointer. This is pass by reference using reference. I like it because I have to put less things to remember as far as where the special characters go. I just got to remember that the ampersands go in the prototype and in the header, and then everything else is the same from a syntax perspective. Now, if I want to do pass by reference using pointer, that's this example. That one was 5.6 from your sample. This is 5.5. So in order to do this, it's just a syntax difference. Everything else is the same. But here, you got to have the indirection operator in your prototype, right there. You got to have the indirection operator in the header tier of the definition. When you pass it, you got to pass by reference. I mean, using the address operator there, and there. And then, when you read data in, you got to use the indirection operator. Otherwise, it works exactly the same. These, when this gets read in, it's pointing to the variable. This here is pointing to the variable name. This is pointing to the variable age, pointing to numpets. So when you read the data in, it writes it to those variables in the calling function, which is main. If I build this and I debug, enter the same thing, 21, 1 pet, it behaves exactly the same. So that's it for this SuncatByte. Very powerful and important concept to learn. So if you have any questions or comments or concerns, please do ask me during this on the discussion board forum during office hours, or shoot me an email. That's it for now. Talk to you soon. Take care. Bye.